Okay, one of the things that we can now think about also is that we can compare different ratios to see which one really is a better deal or which thing is more expensive. So I want us to really think about how we can take all these ratios and deal with what are called unit rates. And unit just means one. We're going to use that same thinking later this spring around percentages, so we'll really try to think about that a lot. Unit just meaning one. So for example, like if I know that I could buy 5 oranges for $1.60 at one store, but which actually is a remarkably good price, but that's okay. Or I could buy 8 oranges at a different store. Let's say that this one here is store A, and let's say this one here is store B. And the second store sells oranges for, let's see, $2 for eight oranges, sorry. So what I could look first and say, well, I know that store B costs more money, so I'm going to shop at store A. But what we really want to find out is, one of the things we could find out is how much each orange costs. And that each means one. Just like each box in your ratio work was one box. Each orange is one orange. So I know that what I want to do is that I have spent $1.60 and I'm sharing that with 5 oranges. So I have $1.60 and I'm sharing it with 5 oranges. On the other hand, I could say also that I have $2 and I'm sharing that with 8 oranges. So here, I'm going to just do my division. 5 goes into $1.60. And this is going to give me what 1 orange is at store A. 1 orange, sorry, at store A. And this one here is going to give me 1 orange, but this one is going to be at store B. Okay, so let's see, I'm going to do the long division. 5 goes into 1, 0 times, 0 I subtract, bring down the 6. 5 goes into 16. Oh, I'm sorry, I probably didn't say that clearly enough. My decimal went straight up. 5 goes into 16 3 times. 3 times 5 is 15. I subtract, I have a 1, I bring down to 0. 5 goes into 10 twice. 2 times 5 is 10. I subtract. Now, this 32 here, 0.32, is the same thing as 32 cents. What does that tell me? Each orange is 32 cents at store A. Store A, 32 cents per orange. Meanwhile, at store B, I would do the same sort of thing, except this time I have 8 oranges for $2. So let's see what I have here. I'm going to put my decimal straight up. 8 goes into 2 0 times. I subtract. I bring down the 0. 8 goes into 20 twice. I have a 16. I subtract. I bring down I subtract. I get a 4. I bring down a 0. 8 goes into 40 5 times. 5 times 8 is 40. I subtract. I'm left with nothing. This time, this 0.25 means that at store B, each orange ends up costing me 25 cents. So now you can easily compare which is the better place to buy oranges because you know how much each orange is worth. So in this case, I would totally pick store B because it is, again, only 25 cents. Oops, sorry. Click the eraser instead of the pen. 25 cents, whereas at store A, it is, over here, 32 cents. So today's classwork is going to be just like that. How much does each orange cost? How much does each movie ticket cost? How much does each battery cost? Those sorts of things. But I do want to show you something a little bit different too. That what you could do for this same situation of the, we have store A here, and that was 5 oranges. Again, sorry for my terrible handwriting, for $1.60. Oops. And then I could say here that I have at store B, I have 8 oranges for $2. So now what I can do, instead of finding what it would be for 1 orange, what I could also do is find out how much it would be for a number of oranges to figure out when they're going to actually be the same number. So I could say that I know I could find 5 oranges, and I could keep thinking about multiples of 5. So, 5, 10, 15, 20, 25, 30, etc., etc. 35, 40, 45, 50. And you could do the same thing over here with from store B. I have 8, 16, 24, 32, 40, 48, 56, 64, etc. And I can see where they match up is at 40. So that means I could buy 40 oranges from store B, 40 oranges from store A, and then I could compare them. So let's do that. Okay, so for store A, for store A, I'm going to say I could buy 5 oranges. Sorry, I'm just going to put the oranges in the front. 5 oranges for $1.60. And that's the same thing as, now I know I want to buy 40 over here to figure out how much it costs. And I know I multiplied that by 8. 5 times 8 is 40. So I'm going to do the same thing over here. $1.60 times 8. 0, 8. 8 times 6 is 48. I'm going to carry the 4. 8 times 1 is 8. Plus 4 is 12. I have 2 numbers behind my decimal. So I'm going to have $2 numbers behind my decimal. So this is store A is going to cost me $12.80 for 40 oranges. Now what I'm going to do is I'm going to look at store B. For store B, I'm going to say that I have 8 oranges originally for $2. So these are my oranges on the top. So I'd say here's 40 oranges. And now I can say, how many times what would I have to do here? I have to multiply by 5. So that means I'd have to multiply here by 5. And I end up getting $2 times 5 equals 10, or $10. So I can see this is another way I get the same exact meaning out of my problem, but that here at store B, I know I could buy 40 oranges for $16, whereas at store A, I could buy 40 oranges for $12.80. And I mean, it's really pretty obvious this way also. On the last one, the 25 cents, 32 cents, it's not that different, 7 cents an orange. But I think you can really see here as the numbers of oranges get larger, that we can really tell that I'm going to end up spending I'm going to end up spending a lot more money here at store, I'm going to spend a lot more money at store A, right? I can see that, versus here at store B. $10 is a lot less than $12.80. We get the same information, we're just comparing it in different ways. Okay, so I want you to try this idea from the first slide out, and then check your answers with Mr. Fries when you're done.